Hey, thank you so much for taking the time out to be a part of this webinar, where we are going to be talking about how you can actually master your application deployment and monitoring strategies over to Google Cloud. What are the different best practices that are recommended by Google Cloud itself? And this is more going to be like sort of like a storytelling session where we're going to be demonstrating a particular use case that we've had with one of our customers. And they recently migrated over to Google Cloud. And now their infrastructure was slowly and gradually growing as they were deploying newer and newer apps. But as they were scaling up, they started getting a lot of bottlenecks and challenges. And how we help them solve those challenges by applying these best practices for their operational excellence. A bit information on me. So my name is Sumat, and I work as a global cloud practice head within Royal Cyber. And with me is Onan, who is our senior GCP cloud architect. And together, we're going to be talking about this overall agenda, where we're going to start off with introductions. Then we're going to go into operational excellence framework. What is the importance? What the actual framework is. From there, we're going to jump into applying that operational excellence within the use case that I just talked about minutes ago. And then we have an exclusive demo for you folks where Nan will help you demonstrate how these different operations work within the cloud environment. And and in the end, we have an exclusive offer for all of the webinar attendees who can leverage our services with some hidden aspect, right? So, and then after that, we're going to jump into this. So, a bit about Royal Cyber. So, Royal Cyber is a IT consulting and a digital transformation company. We've been working in the market for more than 20 years now, with a global employee stamp of more than 2,000, working in 10 different countries, saturated in 5 different continents. And overall, we have 600 plus clients globally spread across the world. All of those clients are majorly Fortune 100 and Fortune 500 companies. And we have more than 250 plus certified consultants in different areas. And these are some of the customers that we have worked throughout the world, specifically North America, Europe, Australia, and the Middle Eastern region. Some of the verticals that we excel in: healthcare, retail, manufacturing, banking, finance, and emerging technologies. These are some of the business partners. Like we in US, we're board partners with Azure, with Azure, and Google Cloud is a partner, and Oracle is a partner. So now I'm going to start off with the operational excellence framework, right? What actually operational excellence framework is, what is the importance of that framework? So by definition, operational excellence is about building a framework for continuous delivery and services on Google Cloud itself. So incorporate it this way, that whenever you're trying to adopt to any cloud, any of the hyperscalers, let's say in this aspect, Google Cloud, migrating to a particular, not even to Google Cloud or any of the hyperscalers, is only one part of the equation, because that's a one-time activity that will just happen, come, and then go. But after that, the support, monitoring, and the overall delivery, that's an ongoing activity that's going to keep on happening till you are using that infrastructure, right? It's going to keep on happening, and it will always be in one morph scenario or to another morph scenario, but you would always keep on happening on that, right? So it's very important for every business to actually have an operational excellence framework, because once you have built that framework on Google Cloud, basically it helps you build a resilient availability, scalability, and an automated infrastructure that can help you do continuous delivery and do continuous integrations with all of the cloud services over to your business use cases. If you talk about what operational excellence framework highlights, so So as best practices, these are some of the key pointers that we do need to keep in mind while we are trying to apply this framework on any of the infrastructure on Google Cloud. Like automating with deployments, setting up monitoring alerts and logging, establishing cloud support and escalation process, managing your capacity and quota, planning for peak and launch events, and then creating a culture of automation. All of these combined together helps you create that operational excellence framework, which would in turn be helpful in releasing your future applications, your features over to your workloads, and then be able to monitor them, set up the right alerts, checking the right logs, debugging them, and helping them create an escalation process. So overall, creating an environment and a culture of automation, support, escalation, and eventually remediation. So this is where we're going to talk about the use case itself. So this is for one of the customers that we were actually working on, and they were heavily invested in GKE, which is the managed services portion for managed service for Kubernetes on Google. And this is what it looked like while they migrated over to Google Cloud. And as you can see, they have some base level of GKE clusters deployed with some microservices running within the pods itself. And then you have the PubSub, bus relay, which is used for messaging and then communication between the pods itself. They were using MongoDB and Cloud SQL as their databases, and then they had some decent, CI/CD pipelines deployed using Cloud Build and were using Bitbucket repositories as their core repository structure. So now I would like to move into the aspect of applying these operational excellence. So what we're going to do now, we're going to check on all of the operational excellence items that we just saw 2 slides ago. And then we're going to apply them onto this framework bit by bit. And we're going to see how this framework is going to change and other aspects are going to get added into it to help us build this framework and solve those problems and issues. So first is automating your deployment. So what we did was we created very specific separate environments for dev, QA, and production. And then all of those separate environments had their own dedicated repositories, which were like the central source of truth. And then we had mapped users to those specific repositories. For example, for the dev and the production environment, we mapped the developers. And for the QA environment, we actually mapped the QA engineers towards those repositories where they were pushing up the code. The code gets picked up by Cloud Build. A new build is created on Artifactory and then deployed over to GKE for that particular part, right? So what this actually helped us do was automate the deployment process for all of the environments, or let alone. And all the developers had to do was just write the code, test the code, push the code to the repository, and then eventually create a new build, QA the build, and then eventually push it to production. So this created a seamless integration between all of the environments, and then all of the environments working synonymously together for shipping out new features onto the production and be available to the general public. The second aspect that we did was setting up monitoring, alerting, and logging structure. So in this particular area, what we did was we created a separate project within Google Cloud, which was solely responsible for monitoring. So this was born under a shared library structure where one monitoring instance was actually shared between all of the environments and their respective instances, and specifically the GKE clusters. Now, what that had us do was set up a centralized monitoring structure within the customer's environment, and it was much easier for the developers, for the QA engineers to debug issues and challenges, and for the DevOps engineers as well, through utilizing that single core of monitoring pane. And from there, they were able to extract reports, generate logs, and set up alerts as well with using cloud monitoring. These alerts would then be utilized in terms of creating the right support structure and then be able to create the right escalation process as well, as we're going to see in the next slide. So once we had the monitoring structure built in as a single core entity that was integrated with all of the three environments. We then integrated them with escalation processes that were distributed into, team supports of L1, L2, and 3. Sorry about the typo. I was supposed to write L2 and L3 into it, but you get the idea, right? So it was like, the L1 team, L2 team, L3 team. So basically, these alerts helped escalate the process to the right team for the right type of remediation that they would expect. As you know, L1, L2, L3 has different SLAs that they need to follow in terms of remediating those issues. And by setting up a centralized cloud monitoring structure, we were able to generate those alerts much quicker, much faster to the right team. And then those teams would immediately jump in, solve the issue, and remediate the problem. The other good aspect of these escalations was that these escalations can have multiple channels of pinging those teams. So, like, for example, you can send out emails, you can connect with third-party apps. Like, for example, in this particular case, what we did was we sent out an email to the right team, to the right responding team, and then we used a cloud function to send out the ticket message or ticket description to their Slack channels as well. And they would immediately be pinged on the Slack, send out an email, the team would be immediately available to rectify and solve the issue. The other aspect of this was to manage the capacity and the quota. Now, one thing that a lot of businesses they do tend to get challenges is to understand what capacity and quota that they need to adhere to in order for them to run their workloads in a more optimized fashion. So what we did was we helped them understand their capacity by, first of all, understanding the workloads, traffic, traffic process, and the utilizations that they were going through. And then from there, we were able to map up the quotas that were eventually integrated to the alerting and the monitoring structure that was centralized within the previous structure itself. And what they did was, so eventually, if any of their workloads would hit a quota, again, those quotas are defined by the business, which would adhere to their billing and budget capacities. So once they hit that quota, an automatic alert would get generated and then be informed to the right IT managers and IT team, and they would just, jump in and try to escalate the issue or try to remediate the problem. So that way, we were able to manage the whole overall quota structure and the capacity planning for the customer itself. After all of this was said and done, after applying all of the best practices into it, this is what the final infrastructure actually looked like. So we had the dedicated GKE workload that was already available. We integrated that with the next capacity that we had by applying the best operational frameworks. And from there, the customer was able to have a very seamless deployment and integration structure within their company. This helped the customer not only be able to deploy new apps and new features, roll out new milestones much easier, but it also helped them create that automation environment, that automation structure that I was actually talking about. So by doing this, the next step that we did was we conducted a few workshops, trained their team, and helped them create that automation environment, that automation mindset, which would eventually help them automate a lot of their processes, which were previously handled manually by certain engineers. And by integrating all of that workflows within Google Cloud, we were able to structure the whole landscape from inception to deployment to QA to release, and eventually be available to the general public itself. Now, I would like to hand over the mic to Nen, where he's going to be demonstrating, how all of this works together in terms of the overall deployment strategy itself.
All right. Thank you so much, Sumer, for the introduction and the initial presentation slides. Now moving towards the demo, I'm Mahmoud Hanan. I'm serving as the cloud engineering manager at Royal Cyber. I've been in the cloud space for more than 8 years now. And at Royal Cyber, I'm actively involved in the Google Cloud practice. And today I'll be giving you a quick demonstration on the operational excellence on GCP. Now, before I jump into the demo, I just like to have a little bit of insight and share some light on the overall demo agenda. So we'll be focusing on uh, how we can automate deployments, and we'll be evaluating a deployment strategy. We'll go through a centralized pipeline on cloud build. We will run a sample pipeline on cloud build to deploy a microservice, and then we'll go right into an overview of cloud monitoring tool, which is a native tool for alerting and incident response, and monitoring all the services and resources that are deployed on GCP. So that's the agenda, right? And within the cloud monitoring tool, we'll be focusing primarily on the dashboards, alerts, notification channel, and uptime checks, right? So that's more or less the demo agenda. We will be able to see all the various pipelines which are already built over there. And I'm just going to take a few minutes to go through some of the core pipelines, right? So these are the build history. And if I go into the triggers, we'll be able to see all these different pipelines that we use to deploy that specific application to a particular environment, right? And notice if I go into infrastructure create, this is one of our central pipelines, right? So we have different pipelines for API, for PDF, for plugin, all these microservices, right? And if I go into any specific, let's say, and if I go into email one, right, we will be able to see, okay, this specific pipeline gets triggered every time there's a new push to the branch. So whenever anything gets pushed to the UAT branch, automatically it pulls the latest code from Bitbucket, right, and then from branch UAT, and it basically has an inline policy. And if we go into that specific inline policy, we'll be able to see that, okay, it builds the cloud image, it builds the Docker image, it basically push the artifacts to GKE. It also pushes the artifacts to the artifact registry, and then it applies the build and it deploys the application. So very simple, straightforward pipeline that we have to deploy a specific microservice. And of course, we'll be getting into more details of it. We'll be running this one, but the pipeline that I actually want to show you today is our infrastructure or centralized pipeline. So the same methodology that we've followed for individual microservices, we've adopted the same for this one as well. The only difference is that we have the invocation is manual, right? And the reason is because this is something we don't want to get triggered every time a new code is pushed to the branch. In fact, this is something which is precisely more related to the overall infrastructure management as well as code deployment, right? So again, if I go into the inline policy, and of course this is something which can also reside in a repository, but if I look into that, not only are we initializing Terraform, or we are building the entire infrastructure to a Terraform which resides in a Terraform repository, but as soon as the entire infrastructure, which includes GKE, which includes pub subtopics, which includes cloud storage, which includes our load balancers, which includes all our monitoring components that I'll be talking about, like the cloud dashboard, the alerts, the uptime checks, all of that gets created automatically through Terraform, right? So we've got Terraform engineers, we've got experts who build these scripts, right, through a module-based strategy, and then these centralized infrastructure pipelines, they consume these Terraform modules, these Terraform scripts to create infrastructure from scratch. So think about this: when you're going from one environment to another, when you're going from development to UAT, or you're going from development to QA environment, right? You don't need to build infrastructure manually. You don't need to do anything manually. All the access roles that are required, all the service accounts, all the cloud storage buckets, all of that gets created automatically through Terraform, right? And once the infrastructure is there, the next thing which this centralized pipeline does is then it starts deploying code. So we have a microservice for web CMS secrets. We have a microservice for our scan engine. We have an API gateway. We have a PDF scanner, a PDF import export service, right? Whatever these services are for a specific application, all those services, the latest image which is there in the artifact registry, this centralized pipeline. It pulls that specific image, and then it deploys it in the GKE cluster, right? So not only does this pipeline creates infrastructure, it also deploys the latest code to that infrastructure, and it basically provisions the entire environment and make sure that application is up and running. So not only does this sort of centralized pipeline help when we are moving from one environment to another environment, but one of the use cases which our customers face is that okay, they're building a new feature, right? And that feature is not something that they want to take on development environment, right? So they need an ephemeral environment. So this is where we can utilize such pipelines and create ephemeral environments, right? And then those ephemeral environments, the new features could be tested on that, and if they are stable enough, right, then we can roll it out to dev, or probably directly to QA UAT as required, right? So this is extremely helpful. I'm going to go back and just trigger one pipeline just to give you the look and feel of how it looks like, right? So it's a completely managed deployment tool, right? Managed by Google, right? And that's the beauty of it. And from a cost perspective, from a management perspective, it's very optimized, right? So if I just go and run a specific, let's say, email microservice, right, which I want to deploy on my GKE, I'm just going to go and run this specific trigger. And what happens is now, if I go to the build history, it is now the pipeline is triggered, and now it's gone into its building state, right? So if I go into a specific build, I'll be able to see the console output, right? And I'll be able to see, okay, now it's pulling the image, it's going to build the image, it's going to build the Docker image, then it's going to, if there are any test cases, those test cases will be applied, then it's going to push that specific code to GKE, to artifact registry, and then it's gonna, sorry, first it's gonna push it to artifact registry, then it's going to deploy it to GKE cluster, and then it will ensure a prepare deployment, and then it's going to apply that specific deployment which is ready. So we can have as many steps as we want. The cloud build syntax is very elaborative, right? It is something that you can go and you can look into the documentations, and it's of course our engineers at Royal Cyber, they specialize in cloud build deployments, right? Whether it's individual microservices, whether it's centralized pipelines. So they specialize in that area, and they ensure that not only your application is smoothly deployed, but even think about it from a DR perspective, right? Think about it from an infrastructure SLO and SLI perspective, right? These infrastructure pipelines, this help, right? And then you don't need a dedicated team, let's say a dedicated admin team that would be managing Jenkins, right? Because we've seen teams which are managing those deployment servers. It becomes quite expensive. It becomes quite tedious, right? So we are leveraging this managed deployment tool as Cloud Build, and that works exceptionally good, right? So that's the main idea. Anyway, so while this deployment is in process, right, I think it's going to take 7 to 8 minutes. I'm going to jump on the second part of the demonstration, and that's the cloud build, right? So if I precisely uh, go back to our UAT project, give me 1 second, right? So if I go to cloud monitoring, and this is basically the native tool that we are leveraging to ensure our alerting and monitoring strategy, right? So GCP gives a very comprehensive monitoring tool to ensure that your applications are up, to ensure that the proper alerting is set up, to ensure that if there are any incidents, we can respond to it accordingly, and then the integrations as well, right? So the very first thing that I want to go into is dashboard, right? So now there are some custom dashboards that of course we can design as per requirements, and there are some native dashboards out of the box which are also available, right? So if our application is deployed in GKE, for example, right, we can go and we can leverage this native GKE dashboard, right? And what it does is that it shows you, the cluster. It shows you if there are any open incidents, right? It shows you, if there are any informations, any alerts, any warnings, right? So on and so forth. And then if you look at this is a very helpful tab, right? It tells you how many errors have logged, right? So there's another service, dedicated service on GCP, which is the logging tool, right? So whenever there is any specific service which breaks, which produces any sort of error, there's a log entry which is generated in Google Cloud Login, right? So right now we can see that there are 5,000 and 624 logs, that error logs that have been generated for this specific test application, right? And then from a CPU utilization perspective, right, if let's suppose it's a 4 core 4 CPU, so almost 43% CPU utilization is achieved, almost 28% memory utilization is achieved, so on and so forth, right? So we have this insights for all the 4 golden standards of visualization. Then we can see all our namespaces, and we can actually see, okay, this specific namespace, right, has all the error logs, right? And then these are the microservices which are utilizing the most CPU utilization. So a very detailed graph, right? What is the node status, what is the workload status, so on and so forth. So it gives you a very comprehensive dashboarding, visualization to monitor your GK environment, right? And same is the case with other services as well. You talk about Cloud SQL database, right? Most of the clients on Google Cloud, they leverage Cloud SQL, so we can see what is the instance state, we can see the replication state, we can see, okay, whether the backups are correctly, whether the database is correctly backing up, whether there are any failures in backup. We can look into Cloud SQL logs, right? And if there are any errors, we can probably filter those errors out, and see if there are any errors that for our Cloud SQL log entries, right? And then of course, this is the native tools, right? So that is something we can leverage, but we also have the ability to create custom dashboards as well, right? So we can go to the and create a new dashboard, and then add a widget itself, right? So it gives you the ability to create a chart from default metrics, from logs, from alerting policies, from incidents, from SLOs, right? And all of this is something which we specialize, and you don't have to create anything manually, right? For this demonstrations, I might be picking and choosing things from an explanation point of view from console, but when it comes to our centralized infrastructure pipeline, all these widgets, all these alerts, all these uptime checks, they all get created automatically just by clicking run on Cloud Build. That's what we do, right? That's the main value that we give to our customers. But just from an information perspective, right, we can see that one thing is that the Google Cloud gives you some of the default dashboards, but we can also create custom dashboards from custom metrics. So if you look into here, if I just want to visualize, okay, what is the CPU utilization for my container, I can precisely go to the specific metric, and I can apply this, and automatically it's going to fetch the CPU utilization for that specific container or that specific cluster, right? And then I have this display dashboards where I can modify the analysis mode, the thresholds, the y axis parameters. I can add more filters, right? And then filter it out based on project ID, cluster name, namespace, right? So for example, if I select namespace, I'm just interested in my cube system namespace, right? So it's gonna filter it out and give you that specific drill down visualization that's required, right? So I can go ahead and I can create this. I can add another widget specifically on error logs if that's what's needed, right? So I can select errors, and then I can apply that, and then that specific dashboard is going to visualize, chart is going to give me the visuals of all the logs with their specific severity, right? And now this again, I need to mention this process is not manual, right? When we create these dashboards through our automated Terraform scripts, right, we ensure all the 4 golden SRE principles which Sumer talked about, right, from the Google Cloud Framework. They're all covered extensively, right? So we talk about errors, we talk about saturations, CPU utilization, memory utilization, error counts, latency, request count, right? All of that, incoming traffic on load balancers, all the relevant charts get created, and we give you a centralized dashboard which is applicable for your specific application requirements, right? So that's how we leverage cloud monitoring dashboard to its maximum, right? The next thing which I want to focus on is, of course, the alerting part, right? So once we have dashboards, right, and of course, if we go back to these custom dashboards, right, for any specific, let's say, dashboard that we've created, we can create we can convert that into we can view that in the logs explorer as well, right? So that's one thing that I missed. And then once we view it in the cloud explorer, right, it takes you to the metrics explorer itself, where we can have detailed visualization of that specific metric. And then the ability is that for all the metrics that we are visualizing within the dashboard or within the metrics explorer, we can then go to alerting policies, and then we can create subsequent alerting policies as well, right? So just like before, when I created a chart for monitoring CPU utilization for Kubernetes container, right, I can again go and I can say, okay, I wanna let's say if it's my pod, and sorry, if I type container, let's see, okay, so here it is, Kubernetes container, and then CPU utilization, right? So CPU utilization, let's say, I want to create a specific alert based on that, right? So then it will give me, okay, all the namespace, all the containers which are running, and then accordingly, I can create my own alert, right? So this is where I can add further filters if that are required, right? Then from a configuration trigger perspective, I can say, okay, what is my threshold, right? When do I want to create the trigger? So let's say, if I want the value to be, let's say, above 10, right, I wanna create a trigger whenever the value is above 10, right? So it's going to adjust my threshold over here, right? So if any of these specific values cross the request utilization above 10, it's going to create an error, right? And then if I do this next, I can then select a notification channel for this. So Hunan test alert is on my notification channel. And if I quickly show you, what a notification channel is, right? So quickly, if I can come here and I can show you the notification channels. Notification channels are, of course, something which we can leverage. It's something which can, create a notification on a Slack channel. It can send you an email. It can also be a webhook, which can then trigger entire pipelines or automation workflows, right? So if I talk about Hunan alert, it basically sends an email to Mohammed Hunan to my email address, right? So I'm just going to select this specific notification channel for now, right? And then notify on incident closure. If I want, I can check that out. If there's any specific text field I want, I can do that, and then I can just type, okay, Hunan test alert demo policy. That's it, right? So now I have an alerting policy that's going to get triggered whenever the request utilization is going to go above this specific threshold, right? So that's how you can essentially, create these triggers, right? One second. Where is, okay? So finally, I'm going to go in and review it. Okay, and then next, and my God, I think uh, one second. Okay, sorry. Create policy. Think it's okay. It's giving me some errors in the basic field. I will delete this filter. Okay, and now if I create the policy, it's going to get created. All right, so we have an alerting policy that's actually created, right? So if I go and view this specific alerting policy, we have a demo policy that's in place. Now, of course, for this demonstration, I cannot increase that specific value, but let's say if I go and I edit this, and if I say, okay, let's bring the threshold down to let's say 3, just to simulate, okay, simulate an error, right? And if I save this policy, I'm quite sure that within the next 3-4 minutes, 5 minutes, right, I will receive an alert, because now the threshold is here, and of course the alerting policy is shooting up. So we'll wait, and we'll see, right? Hopefully we will get a trigger for this specific container request utilization, right? So while we wait for that specific alerting window, right, of 5 minutes, the next I would like to take you to the uptime checks, right? So uptime check is again from an alerting policy perspective. An alerting policy can be affiliated with a dashboard chart. It can also be affiliated with an uptime check. And the purpose of uptime check is we have Google uptime check servers, which are precisely checking whether your specific application is up or not, right? So it's quite simple, right? So if I go into one of the uptime checks, it's going to ask me, okay, which protocol is it going to be, right? And then if I go to API secure a cloud, right, app.secure a cloud, for example, that's my application. And if I just pick this up, I place it here. So that's my host name, right? And if you want, you can put the path. You can also put in the get request. You can validate whether SSL certificates are required or not. If there are any basic authentication, that can also be provided, right? And then from a response validation perspective, if your API or if your app or if your service is returning anything, you can check that for validation, right? Whether it contains a healthy string, whether it contains a JSON response, so on and so forth. And while I'm talking about that, you can see that I've also received the Google Cloud alerting error, right? So within the 3 minute, 4 minute window here, it basically, triggered. And if I just quickly go into this specific alert, right, and if I see this specific condition, uh, download pictures, right? So you can see that Kubernetes container CPU utilization, right, summary, and it will give you visibility of what the incident was, right? So that's how fast the alerting trigger works, right? So we received that, right? And once that issue will be fixed, we will also receive an acknowledgement as well. So response time is 10. And then if we continue to do this, right, the uptime failure again, just like the alerting policy, we can have a notification channel for this one as well. We can continue. We can then test it out. And okay, the title is and test demo RC. Okay, right. I test this out, it will give me a response or code of 200, right? And so I would ultimately create this specific uptime check alert, right? Uh, Coming back to that specific alert which I've received, right? So this is the alert alerting condition which I've received. Now what I'm going to do is that I'll go back and I'll try to fix that specific issue. We can see within the incident, we've received 2 incidents firing. This specific incident summary is also here. So if I just go and correct my threshold policy, because of course I cannot forcefully decrease the request count. Hopefully this alerting condition will then trigger back an alert that will say, okay, your specific issue is resolved, right? So for now the remediation is that, okay, we increase this to 12, but technically you would want to go and ideally fix that specific issue to utilize this more efficiently, right? So now I fixed this. And similarly, for uptime checks, we will also see that, okay, if it's checking within few minutes, right, all these tabs are going to get green, right? So all these uptime check servers, if they will be able to reach our application, right, it will report the status as green, which will indicate that, okay, uh, that specific service is up, right? And of course, if that service, if that API endpoint gets down, right, within the alerting window, it's going to fire an alert that's going to notify you that, okay, specific application or service is down, right? So that's the main idea, right? And then within the services, we can then further go ahead and create some SLOs and SLIs as required by the application environment, right? We can also leverage integrations with different third-party apps or internal applications as needed, right? So we've got integrations with Active Directory, domain services. We've got integrations with Apache ActiveMQ, Apache Airflow, so on and so forth, right? So all these third-party apps, and some of them are native apps. So we've got native integrations which are also available as part of Google Cloud Monitoring, right? So yeah, I think overall from a monitoring and visibility perspective, I think this is about it. I think I've taken enough time. would like to leverage more time for questions, right? So yeah, I think we'll move on to that. And of course, if there are any questions, you can always reach out to Royal Cyber in the inbox in our support email, and yeah, we'll be happy to answer. So thank you all.
Yeah. Hey everyone. Thank you so much, man, for the very detailed demo. And definitely, we would love to go into questions. But before that, I would like to talk about the exclusive webinar offer. So basically, we're giving anyone who's been a part of the webinar right now. So this is a very exclusive offer for all of you, where we would be doing a 1 week cloud assessment in your environment, and through that we'll be able to create an in-depth report of all the touch points that we that can be optimized, and fixes that can be added, and then how we can help you leverage your infrastructure to best practices on monitoring and alerting and budgeting as well at the same time. So this is an exclusive offer for everyone who's been a part of the webinar. Thank you. Let's we'll move on to questions. And so let me so let me just take out, let's see what the questions are. Just give me one quick minute, let me pull it up. So the question is, how do I identify the gaps in my cloud operations without me even knowing what am I doing wrong or right in terms of the best practices? So that was the question I was trying to address. So the best way is that you map the best practices that you have for that are already defined in the operational framework that is already provided by Google Cloud. And you can also look at the recording that we have for this webinar. And you can map your cloud operations that you're already running and see that which of them fit into the best practices or not. Through that one simple exercise, you'll be able to pinpoint and highlight the gaps that your infrastructure right now has for the cloud operations that are being performed over there. Okay, and the second question is, how do I know when I should be invested in automation? When is it advised to do so and when not? Okay, so basically, in terms of being invested in automation, it's always best that you are invested into automation, because automation on the longer run helps make your life easier, or your people's life, your team's life easier in terms of deployment and integration, and then working around all of that. So there's no right or wrong time for it. Some teams tend to do automation at the very end, and some teams tend to do automation as they go along while they are building their infrastructure. So there's no right and wrong to this, but one thing is for certain, that you do need to invest into automation, because that would help you do continuous delivery when it comes to being more deployment, being more vigilant in terms of deployment, escalations, and your remediations itself. Okay, so the third question is, how do I find what capacity would I require for my workloads to handle my apps? All right, so that's an interesting one. So how do you find and what capacity would it be required? The best way, I think, would be to you looking over the consumption of your current workloads that are running in your VMs, and then understanding the capacity inputs of your workloads that are currently running over there. The best thing about Google Cloud is that it would suggest you to either upgrade or downgrade your workloads or your VMs based on the usage that you would have. So you would be able to understand what is the right capacity for your particular workloads in terms of running your environment over there.
Just
Okay.
just to add, just to
Yeah, sure. Go ahead.
sorry to cut you off. Yeah, I mean, from a capacity perspective, of course, Sumer, just like you said, right? So this is always one of the challenges, even when we sit with customers, right? So initially, they are in the development phase, and they don't have any expectations of what sort of workloads would be required, right? So I think one of the things that we as Royal Cyber suggest to our customers is as soon as we are signing off from the development phase and going into QA UAT, we do a proper load testing, right? And this is where Royal Cyber also specializes in terms of doing load testing on the current application, right? So this what happens is that during the development phase, the infrastructure provisioning is done with baseline configurations, right? We're talking about, let's say, a 4 CPU and a 16 GB GK cluster, right? But as soon as we have an understanding that okay, our active user base would be, let's say, around 10,000 active users daily, right? So we do that specific load testing on our environment, and that gives better ballpark idea of, okay, how much capacity do we need to increase. So that's one thing, right, in terms of load testing. And I think just like we suggested in the demo, setting up the logging and monitoring, right? So that's something which we need to do right from the start, right? So if we have monitoring alerts, monitoring checks, which are continuously monitoring our CPU utilization, our memory utilization, our request count, right? And we are observing that as soon as we increase the load, those thresholds are choking. This is where we can make a decision of how much infrastructure we need to scale, and what is an optimum infrastructure with which we should launch our product, right? So these are like few of the best practices that we can also adopt, just to add few more points to what you said. So yeah, that's all.
All right, thank you. Thank you so much, Milan, for that insightful answer. Yeah, I guess we don't have any other questions apart from that. So again, everyone, thank you so much for taking your time out and being a part of the webinar. I hope you enjoyed as much as me and Hunan did presenting all of this to you. We're looking forward to